In this module, we'll begin covering some of the fundamental Android components needed to build an application. But before we do that, I'd like to talk about a software design pattern that's useful to get a better feel for why components are designed as they are. The Model View Controller Design Pattern, or MVC, is one of the earliest patterns used to describe GUI applications clear back to the late 70s. Almost every GUI since then has been designed around this pattern, or a variation of it. The idea is to create a module application where the model, view, or controller components are easily replaceable with another. This decoupling allows for reuse of components without duplication of code. In addition, the MVC pattern describes roles for each of these components. Where the model is a computer data model that holds information in the form of a database or files. The view provides rendering of the user interface and can also read user input. And finally, a controller that communicates with the model, translates or calculates that information into a human-readable format, and then sends it to the view for rendering. The next question, of course, is, how is this helpful? The Apple iOS and Google Android code, upon first inspection, may appear drastically different. However, both of these mobile operating systems use the MVC pattern in the design of their software architecture. So although different mobile operating systems may have vastly different class names for their controller or view, their function is fundamentally the same. So with that in mind, in Android, the activity class is the controller. The activity is the entry point for an Android application. Each activity is paired with at least one view to provide a presentation, in a sense, for every screen a user sees and interacts with. The activity can also access stored information such as databases and files and passes that information to the view so that the user sees the formatted data. Another important concept that we'll get into more detail later is that all activities follow a life cycle from creation to destruction. Understanding it is critical to understanding an application's behavior. The next Android component we'll cover is the fragment. It is best thought of as a mini activity within an activity. It was introduced to the Android SDK when tablets arrived. A larger screen needed more flexibility to display content, with different parts of the user interface acting independently from another. And finally, in this module, we'll cover intents. Intents are the glue that hold activities and other components together. They provide a messaging mechanism to exchange information. It is most commonly used to launch activities, even those in other applications. This design encourages collaboration between applications and reuse of resources.